Hey, what's up, everybody? Papa Bale. All right, so I'm gonna get in here on this pot real quick. Now there's 200 hertz being forced through the trigger coil. So every time it's activated by the trigger coil, by the magnet, it'll. I'm I'm using a single generator on it with 200 hertz sine wave. So I'm gonna go mess with the single generator real quick. Hello. All right.
Yanni is in the house.
What's up, Yanni? Woo. All right. We're at 150 hertz in on the signal generator input. It's hard to find the right spot here. So we had a voltage drop right there, but a speed increase. So it's leveling out, kind of. But it's a Bedini SSG with primary battery and a charge battery. I was thinking about running a relay to swap those batteries on a timer. I like how fast it's going right now. That's awesome. So I'm gonna go mess with the signal generator again.
I know it's hot, but I think the fan produces more heat.
Turn it off.
No, not that. No.
This one.
Does it produce more heat? Probably.
Maybe. I don't really get much heat on my circuits unless they're working wrong. If they're not working right.
And that's from Coco, and he put a sweaty face on there. A hot, sweaty face.
It's definitely hot.
Yeah.
Wow, that's moving at a nice pace right there.
Yeah, he said that thing is flying.
I wish I had a way to like tack it up real quick, but I don't. It won't read right. We try and get a reading though, and then we'll divide by 3, whatever we get. Well, it says 1905. Divide by 3. It might be right. It's not that fast, but it is going. Like this one over here. Turn this up a little bit. .24 gauge coil allows me to turn the bench power supply all the way up on the voltage side, all the way up on the current side. And it just kind of fills in how much current it needs. It varies, so, you know, I just open it all the way up. Never really takes more than it needs to complete the circuit, so it's always a good bet in my mind. Wow. Yeah, this is running on 12.09 right now. That's whipping along for how little voltage is going into it. So I'm going to choke it up a little bit. We just gained 0.04, 0.05. Like 5/100ths of a volt. Just from me tweaking with the resistance. It's awesome.
I got a poll question. Do you want to see Papa Bale collab with other people in the pulse motor community?
Who do you want to see Papa Bale collab with?
Oh, then you got to get a list of them.
List of names, right?
Yeah,
I
I'll
don't
write
know.
those down later.
All right. Yeah, that's a great question.
So far, 100% yes.
Awesome. Awesome. Yeah, I'm in the mood to do something like that. I got a 3D printer I can throw at the project, so, you know, if you got STL files, you want me to print, send them my way. You know, in a collaboration attempt.
Try to get in the shot.
Oh, am I not in there? Okay. Be like that. All right. So this is a Bedini SSG. This is the primary battery. This is the charge battery. And currently we're running at 12.13 on the drive battery. And we got 12.72 in charge battery. So I'm going to swap those again pretty soon. And we're coming up with an idea on how to swap the batteries using the SSG circuit, and that's with these relays over here. We'll time them. I have latching relays as well, but I like these better because I have more control over what's going on. So we'll run 3 volts through this, and it'll change it, it'll swap. And so what I'm going to do is I'm going to put the output of the SSG on this. That's 5 and 6.
Mike does came in, question mark.
My bad, Mike. I didn't do that on purpose. I hit the back button on my phone and I had bounced out of the stream.
Yeah, and then we said we're gonna head out, we dropped the necessary.
Yeah. You get my message?
He said talk to you later.
All right. Cool, man. I will. I'll talk to you later about this stuff.
He said, nope, the message didn't come. Yeah, I typed a long message saying, thank you so much.
No, we'd love to thank you in the chat. Might have been in the wrong chat. I don't know. I'm not sure, but we did thank you for inviting us
So
on.
you just saw us disappear, that's it.
Yeah, I'm sorry, Mike. That must have looked really bad.
No.
But I was under the impression that we had left you a message there.
Yeah, he said no worries.
Yeah, I left in peace. It's,
That's not good, man. We gotta, was that your first time?
no, that was the second time we did that.
Okay. So yeah, we gotta get better with that.
But it's been, it's a while between times. Maybe we could work on that a little bit.
Yeah, maybe you guys can do it during the day if you're not working.
Yeah, I think that the more often that you do the streaming stuff, the easier that it becomes.
Right.
And it was really easy once I, was focused on it. I got it done. It's really quite straightforward with the settings and everything. So, yeah. Be a lot quicker the next time. But, so, what I'm getting at here is how you make this relay swap the way you want it to. So you basically want your output of your SSG, which is these two, to go to your battery A and battery B. You want to go to both batteries, but when in each swap it'll go to each other battery. Now I have two of these. One for each output. Oh, no. One for the output and one for the input. That's the one we're running today. One for the output, one for the input. I wrote, yeah, man, it's my bad, Mike. I jumped. I screwed it up. But, yeah. It's alright. It's alright. I'll work on it. So we got 12.111212. We're gonna play with the knob here a little bit, see if we can't get it to go higher. Yes. So we got a lot of resistance on there now, you can hear it. I'm gonna go play with the signal generator. Alright, so that's 80 hertz in a signal generator. And our voltage has now gone up to 12.17. Which means we can open it up a little bit. It's going to go down, but that's okay. It's going to go faster. It's going to level out. But 80 hertz, I mean, I think the lower the hertz is good because it's a 16 gauge coil that's like 230 turns. So it's like real thick and it's real tiny. Yeah, I like what we were doing earlier. They were discussing their ideas, and I was learning from them by being an observer and a watcher. And I had my stuff going on here, but it's like a lot of it's pre-built, honestly. I mean, from the cables that I use to the circuit that I'm using to run the wheel here, it's pre-built. I bought it. I do know how to hook up a transistor though. I know how to do all that stuff. I make my own connections. Without solder, I mean solderless connections. I come up with, different ways that you can do that. Yeah, this is definitely generating more heat than air. This fan right here is not generating a lot of air at all. It's not. I mean, I can feel it a little bit, but it's just a little bit. The wheel is definitely not even that much. There's not much air coming off of this at all. Probably more heat than air. I get it now. Oh man. So I think the 24 gauge coil works really good with either a Hall effect sensor or a reed switch. I tried using it in the SSG and it didn't work like I thought it would. I don't know why, but it didn't. It was really slow. Must have been something I did. It might have been the pot wasn't working right. Something must not have been clipped on or something, because it works wonders over there. It's so fast. That is so cool. Let's open it up a little more. Woo! Look at that thing go, man. That's awesome. So cool. All right. All right, that's awesome. So we're hooking up a way, because this is a swappable system, because now the one battery's down to like 12.06. And the charge battery's up to 12.73 now. So I'm gonna give it some time, rest. So now see the battery's going up, or the voltage is going up. Probably can't hear it, but I can hear the signal generator pulses being put in. So I'm going to actually drop the hertz a little bit. Do like a 45. But yeah, that's going to take me some time to set up the relay, but I'm going to set it up, and it's going to swap. I want to do it on like, as fast as my swapper can swap it. So like 1 second maybe, or maybe it's a tenth of a second. But maybe 10 seconds. We'll start at 10 seconds. We'll decrease from there. And what we're going to be doing is we're going to be hooking one of the relays 5 and 6 up to the SSG output, and then we're going to hook up 1 and 2 up to one battery, and 3 and 4 up to another battery. And then we're going to have two of these. We're going to have two of these right here. And then we're going to hook 5 and 6 up to the input, and we're going to hook up and we're going to have them alternate between the two. So when the switch is up, the two up will be like different batteries. You know what I'm trying to say? Good, alright. Cool.
Cool.
But see, the power supply is supposed to connect to the bottom one here. But since we're swapping the power supply, I don't even know if that'll work. I mean, I think it should work because there's no diodes in this thing. Should be like an AC, DC, well, an AC connection going back and forth like this, oscillating. Should be able to oscillate, don't you think? To go from, and be able to go back the other way. So as long as it can do that, we can do what I just said. And I don't even think we need to use this bottom part. I don't know. Oh, we do. We gotta put 3 volts in this part right here. I'm gonna use a power supply to do that. Because I'm learning about the latched relays. Yeah, maybe I'll learn those before I set this up. I have them over there. Anyway, the latched ones kind of do it automatically instead of needing power to be put into them. But you know, you put in 3 volts, but you got to hold the voltage in. So you still need the burst of voltage, but your voltage supply lasts, especially if it's a battery, so much longer with a latched relay than it will with these relays. This one you have to constantly put 3 volts in where you have it on, and then when you have it off, you can just turn it off.
$1,000 views.
What's up? Alright. Gotta do something. 12.69 on the charge. So I don't know. Is it like not charging now? Oh, it is charging. Cool. Oh no, is it not charging? Ah, maybe it's not charging. Alright, we got it all the way opened up right now. It should get going pretty fast. But we're losing, and we're doing something different right now, so it doesn't really matter. We just opened it up all the way, and it's going to start spinning. But the idea is when this one gets up to like 12.75, to swap it, and have this one run, and that one charge. So in order to run the relay swap, I need the batteries to start off at an equal amount. The batteries got to be equal because they do. They have to be equal. Wow, that's moving right along, man. I'm impressed. If I stick my finger in there, it's going to get cut off. Going that fast. Whew. We get the extra 45 hertz pumped into the trigger coil every time a magnet passes. Because I got a signal generator hooked up to the trigger coil. Oh, you're getting some wind right here, blowing this thing. Yeah, I can feel that. What about over here? Yeah, that's where the wind is. Right down here. Wow, there's a lot too. That's probably why it's going so slow, because it's got a design that catches a lot of wind. But it is, of course, a circle, as you can see. I just removed a few pieces of that circle, leaving the edges to form a circle when you spin it fast enough. Because it's definitely not a circle. It's more like a boomerang. I've already swapped them once. I'm going to swap them again right now. But it should. Alright, let me make sure those are hooked up on the right thing. Looks right to me. Now that should be moving really fast. That's like well over 12.5 going. I don't know. So it's gonna spin really fast. So it's like they're both kind of going up right now because I joshed with the resistance. But I think it's all going to go down. But it's all right because we're just learning. You know, we're trying to feel our way to what's going to work. We want to know our numbers, but we don't, like, it's not going to stop us from moving forward. Like, I don't even know the numbers that I need to win on this being like a self-sustaining system. There's like no data that maybe that's not true. I gotta look a little harder. Because when it comes down to it, the answer is always no. And it's got to be something with motion in it. I don't really do the motionless thing too much. I mean, I do sometimes, but not to the extent of like replicating anything. Just, I run a signal generator through a coil, and then I use another coil to pick up what it is, a sensitive coil. And it's really cool because I can like put 3 volts of power in, run the signal generator through this Litz coil that I have, and I can get like 222 AC volts out the other side. You know what I mean? It's not breaking any laws, man. That's 100 strands of 38 gauge wound parallel that has, the total of, 3 volts going through it. The way I think it works is when it makes its imprint, it's like it's so much. You don't need much to make it work well. And you can turn the frequency up with this beast. It's like, I think it was like 427 was the frequency that I was using to get that. It was awesome. I'm like, really? All I have is 3.05 volts going in. But I think even with that low, it was doing in like 800 milliamps though. But anyway, like the message was that this has been cool. Let's do it again. I'm gonna go do a stream on my channel because I actually want to find a way to share my knowledge and what I have, and I want everybody to, and when you're teaching somebody how to build something, you assume they know nothing. That's what you have to assume. I mean, you cannot assume that they know what's going on. That's bad teaching from the start. You can't assume that. You just can't. It doesn't matter what level either. It doesn't matter that you could be a master or an apprentice or a journeyman. You'd never assume that the person standing in front of you knows what's going on. And you should just go to the table with that. Especially if you're trying to teach. And then you don't leave little bits out that are really important. It doesn't seem like a big deal at the time because it's like second nature to you. But, it is a big deal. Like, it's just like a big deal. Because, wow, I don't know. And collabing is the funnest thing in the world to do. Working with other people on things is a great way to expand your knowledge, your database, And, you know, I hope that everything works out for everybody involved. And I hope that, you know, I mean, I have a little bit of resources to lend to projects. I have, like I said, a 3D printer at disposal. STL files are easy to transfer. You know what I'm saying? So if there's any, like, you know, need for that, I have, you know, some resources. I'm not like totally busted, but I feel like I am heading to a point where I have to consolidate. With that being said, I got a bunch of stuff over at the other house, and I'm looking to get rid of probably half of it, if not more. So I'll look into what the rules are about giveaways and stuff, but yeah, I'm looking to give away some stuff. Look at how fast that's going, man. That is really moving. That's awesome.
Minato motor.
The minute motor?
M-I-N-A-T-O.
This one's got 20 volts and 30 milliamps going into it. Just turn up the heat.
Oh, that's someone's last name. He just gave the name.
Okay. Woo!
Oh, I had Minato. He had a scoop fan, looks like.
Yeah, it is a scoop fan. It's not a really good air pusher, but look at it go, man. Wow, dude. That was a signal generator. And that was probably my last transistor. I gotta turn that baby off. And it happened because the table started to bounce and the wires got crossed. It's good that I can narrow this stuff down to a T now. It's like I know exactly what frickin' happened. But that does smell like a burnt transistor to me. And a fried wire.
I smell it now.
Alright, so that's that. For this, I don't have any more transistors at work right now. They're all,
Subscribe.
heck yeah. You want those who wanted to see sparks, there you go. It was going so fast though. Do you see how fast that was going? Oh my lord. That was going fast. This is going fast. Just stick my finger in one of those holes, it's gonna rip right off. $34.24 divided by 2. So that is 15, 17, 12 RPMs. 1712 RPMs.
So did it burnt out, like too hot?
No, the wires crossed. You gotta understand that when this started going really fast, it started bouncing. Okay, and vibrating, the table started vibrating a lot. And when that happened, the signal generator was clipped like right here to the, and it bounced and it got crossed. I don't think the signal generator burnt out. I hope it didn't. But you can see the transistor's got a big old chunk missing. I think that's the only part that got hurt, though. At least that's what I'm hoping. Because first the clips touched, and then the transistor blew. And that was with 45 hertz going into the trigger coil. All that speed, I think, was generated definitely by the hertz being added into the equation. Man, that's so, well, there you go. Like and subscribe. And it's all right. Tomorrow's Wednesday, yeah?
Yes.
I got a shipment coming in on Wednesday. I'll be able to make my coil. So we're gonna have 2 spools of this much, this gauge, 20 gauge. And then I'm gonna have two spools of the 32, and we're gonna make like a coil that's gonna be like 830 turns. So altogether, that would be like 3,200 turns.
500, 800.
Yeah. So it'll be about as fat as the one that's in there right now, but it'll be longer, a little bit longer. At least I'm hoping. I mean, if it looks like it's going to be way too big, I'll make it a little bit smaller, because it is, you know what I'm saying? It's got a lot of current that'll go through it. 20 gauge is pretty big, but it's pretty fat. So I'm wondering if I shouldn't do a 26 gauge trigger instead of a 32 gauge trigger, but then that means I have to wait to buy more copper. So I think I'll just go with 32. It'll work just fine. I'm going to have 2 32 gauge triggers and 2 20 gauge drive strands for the dual drive. And I'm hoping having the extra trigger strand in there will allow me to use 2 SSGs in the same coil. I have yet to be able to do that. I've only been able to do an SSG and then one of my 1, 2, 3 circuits. But that works really good too. It works great. I want to do the SSG one, and I want to do a battery thing with each one. I'm not sure which battery thing I want to do. It's either going to be 1 battery per, or it's going to be 2 batteries per. Because I have 2 other batteries. They're not the same size batteries, but I think you can use the same, like, I have 2 sizes like this and 2 like this. So the big one, but they're swapping, so I don't know. me to do the swapping thing. Huh?
Yanni said he's gonna send some info.
Thanks, Yanni. All right. So who else saw that, like, starting to bounce, like, shake like this? Anybody see that?
I bet if you rewind it, and zoom in, you can see it good.
Heck yeah. Oh, man. Well, that's a bummer. Just as I was unclipping the power, man, it happened right then. I was like, fraction of a second too late.
Yeah.
But that 24-inch coil is really nice with the reed switch. Like, really nice.
Yeah, you sent it to the Discord.
Nice. Alright. Is this the self-sustaining info that I need?
Yeah, the numbers need to be correct, resistance, etc. I'm gonna check out sources, try to do the math. He's gonna try to do it.
Awesome, man.
Or like he said, he sent it, that's right.
Yeah, I'm gonna try and move these coils in a little bit, see if we can't get a little bit more burst out of it. I'm gonna remove the imbecile. I'm going to remove the rotor that blew up my transistor. Now we can see what I'm doing. Bam. Boom! Shakalaka. Nice high frequency right there for a pulse motor, I think. Let's think. 3386 divided by 2. So it's almost as high as it was before in like a third of the time. 34, 39, 34. 3,500. Bam. 3750. Or no, 1750 RPMs. I think that's awesome. I found this hanging on the wall. The reed switch was hanging on the wall, and I'm like, I'm gonna try this. And it works really, really good. So I was like, woo! I mean, look, we're drawing 443 milliamps at 31 volts, and we're going like 1800 RPMs. That's phenomenal to me, because usually I'm drawing 200 to 400 milliamps. This is nothing. I mean, even if we multiply it out to watts, I'm telling you, this is fewer watts than I spend at 12 volts with other coils.
Society of High Science is in the house.
Hello, society. Woo! I just blew my last transistor. So I'm working with a reed switch. $34.92. $34.92. So $17.50. That's as fast as that one's gonna go the way it's hooked up. Oh yeah, man, that's awesome. Oh. So if you can see it, I don't know if you can see it, the transistor exploded. It was going so fast that it was starting to bounce the table, and I had a signal generator hooked up right here, and it just bounced everything together, and it sparked, and then the transistor blew. It looks like everything else is okay though. So thumbs up for the circuit, man. I mean, that will probably happen again. Maybe not that exact scenario, but something like that will happen. I'm going to try using a Hall effect sensor, like so, with the SSG. Should be interesting to see how that works out. Sometime tomorrow I will have 15 more transistors. And then sometime between now and the 27th, I'll have 10 more of the MJL 2194s. 21194s. The G style, I guess. But those, they don't have them readily available at Amazon, so it takes longer to get those ones. You gotta pay the shipping costs. Alright, ladies and gentlemen, I think we're gonna call it until I get those items. It'll be tomorrow sometime, and I'll set it back up and we'll get going on that.
2,000 views.
Whoa. But I think the signal generator had a lot to do with how much speed we were getting right there. We sent it like a weak pulse, like a turntable pulse through the trigger coil, and God, it worked so much wonders. It made everything go up. It was so cool. But yeah, I'm gonna try and get this place a little bit more cleaned up. We're gonna sort everything out. We're gonna get everything where it needs to go, and then we're gonna have some giveaways. I'm pretty sure I got some stuff that you all want, some people want, and we'll see if I can get it to you. And there's a lot of stuff here that nobody would want, so you know, I'm not trying to say anything really. I'm just trying to give some stuff to you. Yeah, I know that's goofy. It's goofy, but yeah, it works. I'm just trying to not have to throw it out, you know what I'm saying? So, peace out. Have a wonderful night. Please subscribe. Hit the like button. Bye now. I don't know, should I keep going?
Just let it run for a little bit.
Yeah, I could do that. I'm gonna turn this back on. What'd you put in there? You put anything in there?
So hit the like button. Subscribe. Thanks for dropping in. We are working on pulse motor experimentation. We did have the transistor blow earlier in the broadcast. If you want to look back.
See the figure there. It's like God. Yeah, big spider. What are you doing? Twig, twig. So, I need to encourage all it's like for check on this motor.